What's up, party people? I'm here to teach you today about some rotations, and nothing I rotate more than these two pythons on the dance floor.
Where did we get this guy?
First thing we do is review a transformation. That's a change in the position of a geometric figure. So in this chapter, we're going to talk about three different types of transformations: reflections, translations, and rotations. In this particular instance down here, we have our initial figure that we call our pre-image. We're going to talk about that more in a second. Our initial figure, our pre-image, is triangle ABC, and it undergoes some type of transformation in order to get our resulting figure, which we call our image, triangle A prime, B prime, C prime. In this case, it was a translation, a slide. Over here, we have our initial figure, triangle XYZ, which we call our pre-image. It undergoes some type of transformation to end up with our resulting figure, which we call our image, triangle X prime, Y prime, Z prime. In this case, our transformation was a rotation. Now again, we just said the pre-image is your original figure, it's your starting figure, whereas the image is your resulting figure. It's what you get after you take your initial pre-image and perform some type of transformation to it. Next thing we're going to talk about is the center of rotation. That's a fixed point around which all other points and figures rotate. So if we're looking at this Ferris wheel, the center of the Ferris wheel would be the center of rotation because all other points rotate about that center of rotation. Over here we have triangle AOB, and triangle AOB, if we were to rotate it about point O, we would get triangle A prime, B prime, O. Now the reason O doesn't rotate anywhere is because it is the center of rotation, and we'll talk about that more later on. The next vocabulary term is the angle of rotation. That's the angle formed by the pre-image, the center of rotation, and the image points. So here you can see that our pre-image point is point A. Our center of rotation is this point O right here, and then A prime would be our image point. So if we create an angle between our pre-image, our center of rotation, and our image points, we get our angle of rotation, which in this case is 60 degrees. Now, a rotation is a function that maps a point to its image through an angle x degrees, such that if the point is the center of rotation, then the image and the pre-image are the same point. If the point is not the center of rotation, then the image and the pre-image are the same distance from the center of rotation, and the measure of the angle of rotation is x degrees. So, this looks super complicated, but it's not. It's just saying that you have a point and you have its image. Your point is going to be rotated about a center of rotation x degrees. And once you do that, you will get the image of that point. Now there's two scenarios here. If the point is the center of rotation, so P at 0, 0 is our center of rotation, then the image and the pre-image are the same point. So no matter how many degrees you rotate P around the center of rotation, 0, 0, it will still end up being at 0, 0 because the point is the same as the center of rotation. As for part B, we have a point that is not the center of rotation. And when you have a point that's not the center of rotation, you are going to get another image point somewhere else after you rotate that pre-image point a specified number of degrees about the center of rotation. So what we're going to do here is we're going to rotate point P 180 degrees about our center of rotation, the origin, and we end up with our image point P prime at -6, -5. That is how you rotate when your point is not at the center of rotation. Please note that rotations are counterclockwise unless otherwise specified. This is very important because most of the time you will be asked to rotate either a point or a figure, and it will not tell you whether to rotate clockwise or counterclockwise. You just need to know that if it doesn't say, it's telling you to rotate it counterclockwise. Now let's talk about rotations using a protractor. So this is actually pretty tough, so please pay attention. We're going to use a protractor and a ruler to draw a 140 degree rotation of triangle ABC here about point K. So point K is our center of rotation and triangle ABC is our pre-image. We are going to rotate it 140 degrees about point K. So I need you to get a mental image of where this should end up. So 140 degrees, well 90 would be going from here to straight up perpendicular, right? So if it were up here, that would be a rotation of 90 degrees, again, counterclockwise. We always rotate counterclockwise unless otherwise specified. That's why we're not going this way. So we rotate counterclockwise 90 degrees, we get here, and then a little bit more than 90 degrees would be 140 degrees somewhere in this region over here. So this is a good way to double check your work. Our 140 140-degree rotation of triangle ABC should end up somewhere right here. Well, let's see. First, we are going to draw a line segment connecting K to A. So we're going to rotate point A first. That means we need to draw a line segment connecting point K and A. Next, we're going to draw a 140-degree angle, placing point K in the center of the protractor and KA on the bottom line. So we have segment KA, and it's going to go on the bottom line of our protractor. Point K is going to go in the middle of our protractor. And remember, because we are rotating counterclockwise, we know that we're going to orient our protractor up instead of downward. If we needed to rotate this point this way, clockwise, then we would have our protractor going upside down. But in this instance, we are going counterclockwise, so we need to have our degrees up here. Now, it says we're going to draw a 140-degree angle, placing K in the center, done, and segment KA on the bottom line. Sweet. So all we have to do now is draw our angle. We're going to look at the bottom numbers here because those correspond with our angle that we're forming right here with segment KA. So we raise to 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Next, I'm going to draw a ray that is starting at point K and going through that 140-degree line, thereby creating that 140-degree angle with segment KA. Now that I've done that, I'm going to use a ruler to draw A prime, the image of point A rotated 140 degrees about point K. And how do I do that? I need the measure of KA to be the same as the measure of KA prime. So to do this, I measure the distance between point K and point A with a ruler. Now that I have that distance, I go over here and I measure that same distance on the 140-degree angle that I drew. And I put point A prime at that exact same distance that A is from point K. So these two would be congruent because in rotations, the pre-image and the image points must be the same distance from the center of rotation. We talked about that earlier. Now that I have successfully rotated point A, I need to repeat this for the other two vertices. So let's go ahead and do that. First, I'm going to draw a line segment connecting K to C this time. Now that I've done that, I'm going to draw a 140-degree angle, placing K at the center of my protractor and segment KC on the bottom line of the protractor. Again, my protractor is going to be oriented upward like this because I'm rotating point C counterclockwise. Next, I'm going to draw a ray that is starting at point K and going through that 140-degree line, thereby creating that 140-degree angle with segment KC. Next, I'm going to draw C prime such that the measure of KC is the same as the measure of KC prime, meaning that C prime has to be the same distance that C is away from our center of rotation, point K. Now that I've done that, I can move on to B. Let's connect K and B with a line segment. Let's put our protractor with the center at point K and the bottom line on segment KB. I then draw a ray starting at point K going through 140 degrees. I have now created a 140-degree angle with segment KB. So I can measure the distance from point K to point B and measure that same distance on the 140-degree angle and put B prime. I then connect each of these points, creating triangle A prime, B prime, C prime, which is the image of triangle ABC after it's been rotated 140 degrees about point K.
What's that, people? I guess it's example time.
Now example 1 says copy rectangle PQRS and point M. Then use a protractor and a ruler to draw a 60-degree clockwise rotation of rectangle PQRS about point M. So it's clearly a little different this time in that our center of rotation is inside of our figure. So what we're going to do is we're going to do the exact same thing. We're going to rotate each point about point M, and it's going to be 60 degrees clockwise this time. So we start by rotating point P. We go ahead and draw a line segment connecting M and P. We then draw a 60-degree angle opening clockwise, placing M in the center of the protractor and segment MP on the bottom line. M is the center of rotation, so it's got to go in the center of the protractor. Segment MP has to go on the bottom of the protractor. Now here's the question. Should the protractor open this way or this way? Well, we are rotating P 60 degrees clockwise. So if we're rotating P 60 degrees clockwise, clockwise is this way, right? So 60 degrees clockwise would be over here. So I need my protractor to open this way. And that's because I can rotate P 60 degrees clockwise now. If I had it the other way, I would be rotating P 60 degrees counterclockwise. Okay, so always pay attention to that. So now let's create that 60-degree angle. So again, I'm using this 60-degree line right here rather than this one over here because this would create an obtuse angle, but 60 degree, we want an acute angle. So I'm going to draw a ray going from point M through that 60 degrees right here. I can then figure out how far point P is from our center of rotation, M, and then measure that same distance on the 60-degree line that I drew. And I put P prime, the image of point P after it's been rotated about our center of rotation, point M. Then we're going to do the same thing for every other point. So let's do it with Q. If I want to rotate Q 60 degrees clockwise about point M, that's going to go this way, right? Not this way. So don't put your protractor up here. It should be flipped. It should be like this, where your center of rotation is at point M, and then the bottom line is connected to MQ. Next, I find that 60-degree line. Again, we're not going to use the one that's over here because that would create an obtuse angle. That would be greater than 90 degrees. I want an acute angle, 60 degrees. That should be less than 90 degrees. So we start at point M and draw a ray going through that 60-degree line. We then measure the distance from M to Q. Measure that same distance on the 60-degree line, and we get Q prime, the image of point Q after it's been rotated 60 degrees clockwise about point M. Do the same thing with R. We need to rotate R 60 degrees clockwise about the origin. So 60 degrees clockwise, point R would need to go this way. We set up our protractor the same way we did with Q. We put M at the center of rotation. Segment MR is going to be on the bottom of the protractor, and our protractor is going to be like this right here because we are rotating R 60 degrees clockwise, not counterclockwise. So we find that 60-degree line. Again, we're not going to use the one that's over here because that would create an obtuse angle. We want an acute angle right here, just 60 degrees. So we draw a ray starting at M going through that 60-degree line. We then measure the distance from point M to point R and measure that same distance on our 60-degree line, and that is where R prime is going to go. That's the image of point R after it's been rotated 60 degrees clockwise about point M. Lastly, we do it with point S. We connect M and S. We then need to draw a 60-degree angle opening clockwise, placing M at the center of our protractor and MS on the bottom line. Now the question is our protractor going to open downward or upward? Well, we want S to rotate 60 degrees clockwise about point M. So we need our degrees to be up here. So we place our protractor like this. If we had placed it the other way, we would be rotating S counterclockwise. That's not what we want here. We want a clockwise rotation. So we draw a ray starting at point M, going through the 60-degree line here. Okay, we're not going to use the 60 degrees over here because that would create an obtuse angle. We draw a ray going from point M through our 60-degree line. We then measure the distance from point S to point M. We measure that same distance on the 60-degree line and put S prime, which is our image of point S after it's been rotated about point M 60 degrees clockwise. We then connect each of our image points and we have rectangle P, Q, R, S after it's been rotated 60 degrees clockwise about point M.
Time for you to try.
Okay, we're doing the same thing here, except we are rotating triangle EFG 90 degrees about point L. Now, it doesn't specify whether we're rotating it clockwise or counterclockwise, so we're going to rotate each of these points counterclockwise because you rotate counterclockwise unless otherwise specified. Let's start by drawing a segment connecting L and E. We're going to rotate point E first. Now we are going to draw a 90-degree angle counterclockwise because it does not specify, placing L at the center of the protractor and segment LE on the bottom line of the protractor. Again, we're rotating counterclockwise, so it should end up over here, meaning that our protractor should be oriented upward like this. Now, we're rotating 90 degrees. This one's easy because there aren't two 90-degree lines here. There's only one right in the middle, so we are going to draw a ray going from point L through that 90-degree line right there. Now we measure the distance from point L to point E, and we measure out that same distance on our 90-degree line, and we put E prime. That is the image of point E after it's been rotated 90 degrees counterclockwise about point L. Now we need to repeat that for every other vertex, so let's start with F. We draw a line segment connecting point L and point F. We put point L at the center of the protractor with segment LF on the bottom line. Again, we're rotating 90 degrees counterclockwise, so F should be over here, meaning our protractor should open upward instead of downward like this. Now, again, we go to the 90-degree line. We draw a ray going from our point L through the 90-degree line. We then measure the distance from point L to point F. We measure out that same distance on the 90-degree line, and we put F prime, the image of point F after it's been rotated 90 degrees counterclockwise about point L. We do the same thing with point G. We draw a line segment connecting L and G. We then put L at the middle of the protractor with segment LG on the bottom line. Again, we're rotating 90 degrees counterclockwise, so we need our protractor to open upward. We draw a ray going from point L through the 90 degree line. We measure the distance from point L to point G. We measure out that same distance on the 90 degree line. We put G prime, the image of point G after it's been rotated 90 degrees counterclockwise about point L. We then connect these dots and we have the image of triangle EFG after it's been rotated 90 degrees counterclockwise about point L. Now this is the rotation cheat sheet. So when rotating given points about the origin on the coordinate plane, this is what you need to have memorized. So let's talk through this really quickly. A 90 degrees rotation counterclockwise about the origin. You're going to take whatever your ordered pair is. You're going to flip the X and the Y coordinate, and you're going to make whatever the Y coordinate was the opposite of what it was. A 180 degree rotation. You're going to take the X and the Y coordinate, and you're just going to change the sign. You're going to make the X and the Y coordinate the opposite of what they were. You're going to change the sign. Then the 270 degree rotation, you're going to flip the X and the Y coordinate, and you're going to make the X coordinate the opposite of whatever it was. So all you have to do here is memorize the counterclockwise rotation, because the clockwise rotation cheat sheet is just the flip of whatever the counterclockwise one was. So a 90 degrees counterclockwise rotation is the same as a 270 degree rotation clockwise. A 270 degrees counterclockwise rotation is the same as a 90 degrees clockwise rotation. And 180 degrees is the same either way. So example 2 says triangle PQR has vertices at P, Q, and R. Graph triangle PQR and its image after a rotation 90 degrees about the origin. Okay, cool. So let's graph this triangle. First, we'll start with P. P is at 1, 1, so we go over 1 on the x-axis, up 1 on the y-axis, put point P. Point Q is at 4, 5. We go over 4 on the x-axis, up 5 on the y-axis, put point Q. Point R is at 5, 1. We go over 5 on the x-axis, up 1 on the y-axis, put a point. There is our triangle PQR. Now we're going to rotate this triangle 90 degrees about the origin. And because it doesn't specify, we are rotating 90 degrees counterclockwise. So we're going to use the counterclockwise cheat code here. This says that we are going to flip the X and the Y coordinate and make the Y coordinate the opposite of whatever it was. So here, let's start with P. If I want to rotate P 90 degrees counterclockwise about the origin, I'm going to flip the X and the Y coordinate. Well, that doesn't matter. It's still going to be 1, 1. And let's make the Y coordinate the opposite of whatever it was. Well, it was 1, so it's going to be -1, 1. And that's where P prime is going to be. So we go over to the graph, we go over to -1 on the x-axis, up 1 on the y-axis, put P prime. Next, let's look at Q. We're going to use our cheat code here. We're going to flip the X and the Y coordinate, so it's going to be 5, 4. And then we make the Y coordinate the opposite of what it was. So instead of being 5, 4, it's going to be -5, 4. And that is where Q prime is going to be. So we go over -5 on the x-axis, up 4 on the y-axis, put Q prime. Lastly, point R. We're going to use our cheat code here. We flip the X and the Y coordinate, so instead of being at 5, 1, it's going to be at 1, 5. But we have to make that Y coordinate the opposite of what it was. So instead of being at 1, 5, it's going to be at -1, 5. And that is where we put R prime. So we go over -1 on the x-axis, up 5 on the y-axis, put R prime. That triangle right there is triangle PQR, rotated 90 degrees counterclockwise about the origin.
Now it's time for you to try.
Okay, doing the same thing here. So this time we have a parallelogram, F, G, H, J, with these given vertices. So let's go ahead and graph these first. Point F is at 2, 1. We go over 2 on the x-axis, up 1 on the y-axis, put point F. Point G is at 7, 1. We go over 7 on the x-axis, up 1 on the y-axis, put point G. Point H is at 6, -3. We go over 6 on the x-axis, down -3 on the y-axis, put point H. And point J is at 1, -3. We go over 1 on the x-axis, down -3 on the y-axis. There's point J. So here is our parallelogram, F, G, H, J. We then want to graph the figure, already done, and its image after a rotation of 180 degrees about the origin. So again, it does not specify. But the good news is that the 180 degree rotation clockwise or counterclockwise is exactly the same. And it is to make the X and the Y coordinate the opposite of whatever they are. So if f is at 2 comma 1, then f prime, after being rotated about the origin 180 degrees, is going to be at negative 2 comma negative 1. So we go over negative 2 on the x-axis, down negative 1 on the y-axis, there's f prime. If g is at 7 comma 1, then g prime is going to be at negative 7 comma negative 1. So we go over negative 7 on the x-axis, down negative 1 on the y-axis, there is g prime. Instead of h being at 6 comma negative 3, h prime is going to be at negative 6 comma positive 3. So h prime is going to be over negative 6 on the x-axis, up 3 on the y-axis, and we put h prime. If j is at 1 comma negative 3, that means that j prime, after being rotated 180 degrees about the origin, is going to be at negative 1 comma positive 3. So we go over negative 1 on the x-axis, up positive 3 on the y-axis, we put j prime. There is parallelogram FGHJ after it's been rotated 180 degrees about the origin. So here is the image of parallelogram FGHI after it's been rotated 180 degrees about the origin. Now, example 3 says, given the line y is equal to negative x plus 1, describe the images of the line after the following rotations about the origin. So we're going to take this blue line, this is going to be our pre-image, and we're going to rotate it 90 degrees and 180 degrees about the origin. And since it doesn't specify, it's going to be counterclockwise. So how do I rotate a line? It's actually pretty easy. All you do is just pick 2 points on the line and then rotate those 2 points, and then you draw a line through the new 2 points. So what 2 points lie on this line? Well, you just find 2 points that it goes through. You can pick any 2 points on this line. So I'm going to pick negative 2 comma 3, sure. And I'm going to pick 1 comma 0. Those 2 points now, I'm going to rotate 90 degrees about the origin. So how do I do that? Well, the 90 degrees counterclockwise rotation says that I'm going to take x comma y and make it negative y comma x. So if a is at negative 2 comma 3, then our a prime after a 90 degree counterclockwise rotation is going to be at negative 3 comma negative 2. So I go over negative 3 on the x-axis, down negative 2 on the y-axis, and I put a prime. Then I'm going to rotate this b over here, this other point that I picked, 1 comma 0. So if b is at 1 comma 0, then b prime is going to be at negative 0, or just 0 comma 1. So 0 comma 1, I go over 0 on the x-axis, up 1 on the y-axis, put my b prime, draw a line through those, and that is the image of our given line in blue after it's been rotated 90 degrees counterclockwise about the origin. Now the question does say describe the images. So what do we see between these 2 images? What do we know about these 2 given lines right here? Well, it looks like they're meeting at a 90 degree angle, right? So these lines would technically be perpendicular to one another. Let's look at a 180 degree rotation. So we're going to take A and B, the same 2 points that we picked earlier, and we're going to rotate these 2 points 180 degrees about the origin. Remember the 180 degree rotation, either clockwise or counterclockwise, you just make the x and the y coordinate the opposite of whatever they are. So if A is at negative 2 comma 3, then A prime is going to be at positive 2 comma negative 3. So I go over to positive 2 on the x-axis, down negative 3 on the y-axis, put A prime. If b is at 1 comma 0, then b prime is going to be at negative 1 comma negative 0, or negative 1 comma 0, because you can't make 0 negative. So we go over negative 1 on the x-axis, down 0, so just put a point right there. There's b prime. Draw a line through those, and we now have the image of our given line after it's been rotated 180 degrees about the origin. Now let's describe these. What do we see between these 2 lines? Well, clearly, if the other ones were perpendicular, these ones are parallel to one another.
I already know everything. You try.
Okay, doing the same thing, except this time we have the line y is equal to 2x minus 5. So, first thing we're going to do is pick 2 points on this given line. So let's start with this point right here. How about 3 comma 1? And then this point right here at 0 comma negative 5. So we have 2 points. Now all we have to do is rotate those 2 points 207 degrees and then 180 degrees. And it looks like it's going to be counterclockwise because it doesn't specify. So a 270 degree counterclockwise rotation about the origin. The cheat code for that would be y comma negative x. So I'm going to switch the x and the y coordinates here, and I'm going to make whatever the x coordinate was the opposite. So instead of being at 3 comma 1, a prime is going to be at 1 comma negative 3. So I go over 1 on the x-axis, down negative 3 on the y-axis, there's a prime. Then b is at 0 comma negative 5. If I want a 270 degree rotation counterclockwise, I need it to be y comma negative x. So it's going to be negative 5 comma negative 0, or negative 5 comma 0, because you can't make it negative 0. So we go over negative 5 on the x-axis, up or down 0, there it is, there's b prime. Draw a line through those 2 image points, And we have our image of our given line after it's been rotated 270 degrees counterclockwise about the origin. Now, how are these two related? Let's describe them. It looks like they are, again, perpendicular to one another. So it doesn't matter whether you're rotating a line 90 degrees or 270 degrees, you're going to be perpendicular to the other line. Let's look at the 180 degree rotation now. So the cheat code for that, again, is negative x, negative y. So we take 3, 1, and we just make the x and the y coordinate the opposite of whatever you see. So a prime is going to be at negative 3, negative 1. So we go over negative 3 on the x-axis, down negative 1 on the y-axis. There's a prime. B is at 0, negative 5. So we go B prime is going to be at negative 0, positive 5, or just 0, 5, because you can't make it negative 0. So 0, 5, let's graph that over 0 on the x-axis, up 5 on the y-axis. We put our B prime. We draw a line going through those, and you see that the 180 degree rotation of our line, again, creates a parallel line to our pre-image line.